Yikes! I was almost late to work today. I did some laundry last night and I forgot to move my clothes from the washer into the dryer before I went to sleep, so I had to do it this morning when I woke up. Funny that the washer can wash my clothes by itself and the dryer can dry the clothes by itself, but it requires my intervention to move the clothes from one machine to the other. Also, when I woke up this morning, my coffee maker had made me coffee automatically, but my stove did not make me eggs automatically. Have you ever wondered why all of our menial tasks aren't done by robots already? What is so difficult about moving clothes from the washer to the dryer, or making scrambled eggs? Humans do many seemingly simple tasks without thinking about it, that turn out to be way more complicated than they seem when we actually break the tasks down and try to get a machine to do it. For example, consider all that your body and brain have to do in order to complete a simple task, like picking up this marker and moving it to a new location. First, your eyes have to see the marker and figure out where it is located. Your eyes pick up the light, then transmit information to your brain. Your brain has to separate objects in the foreground that you are interested in, like the marker, from background objects, like the table the marker is sitting on, instead of lumping them together as all one object. Then you need to somehow identify the objects for what they are, such as marker or table. Then you need to figure out the location of the objects you've identified. This is difficult because locations are always expressed as locations relative to some other point. For example, your brain might find the location of the marker relative to your eyes. But in order to successfully pick up the object, you also need to know the location of the marker relative to your hands. In order to do this, you need to, at a minimum, know where your hands are. Next, you need to move your hands to the location of the marker. This is difficult for a couple of reasons. First, your muscles don't actually directly control the location of your hands. Instead, your muscles control the angles of your joints. So, to get your hand into the right location, you need to first figure out what angles of your shoulder, your elbow, and your wrist will get your hand to the right position, and rotate it in the right way to be able to grasp the marker. Secondly, you don't want to just make this motion as fast as possible, or even just at a constant speed. Otherwise, you might knock the marker away instead of picking it up. Instead, you need to constantly adjust the speed and force of muscle exertion in order to achieve smooth and accurate motion. This little story illustrates some of the big categories of robotic study. The problem of seeing the marker and figuring out its location is the problem of sensors and machine vision. This is the second of 3 topics we will study in this class. The problem of knowing where your hands are and figuring out what angles of your joints should be in order to get your hands in the right place is known as kinematics, and that is the first topic that we will be covering in this class. Finally, the problem of achieving smooth and accurate motion is known as the problem of motion control, and that is the third topic we will be covering in this class. By the end of this class, you will be able to build a robot arm that can perform this complete action, finding the location of an object by vision, picking it up, and dropping it off in a new location. In order to accomplish this goal, you'll be using the parts in this kit. I'd like to continue today by giving you an introduction to robotics, while also introducing you to this kit of parts that we will be using throughout this class. You have about 50 different parts in this kit, and these parts represent many of the basic components you need to have in any robotic device. The first thing I'd like you to notice with these parts is that they represent 3 different categories that are usually considered to be 3 different engineering fields: mechanical, electrical, and computing. For example, there are mechanical parts in your kit, such as these servo brackets, which you should have 2 of, this angle bracket, and these linear brackets. Some different kinds of screws and nuts, including these pieces, which are known as standoffs. You have various brackets, including a bracket like this to connect to an inductor, a bracket to connect to a marker, and a few different brackets to connect to your camera. You also have this device called a rack and pinion. The rack is this piece, which looks like a long straight gear on a slide, and the pinion is this little gear over here. A rack and pinion is a mechanical device that's used for converting rotational motion into linear motion. You also have this large bracket, which is used for connecting your camera to this other piece called a baseboard. The baseboard is the piece that we'll use for connecting your robot and securing it to the ground. You also have parts in your kit that are purely or mostly electrical. For example, you have a resistor and 2 LEDs. You have an inductor, which looks like this. And you have this chip. This chip will be used for providing power to our DC motor, and it's a type of chip called a quad half H-bridge. You also have a couple of button switches, which look like this, and this device, which is called a potentiometer. You have a matrix keypad, an LCD screen, and a solderless breadboard, which we'll use for making and testing circuits. You also have a bunch of jumper wires. This little pack of jumper wires that are male on both ends, and a small group of wires that are male on one end and female on the other end. You also have a power supply and a barrel connector for providing this power to your circuit. You also have some devices which cross the boundary between mechanical and electrical realms, most specifically these 5 actuators. You have 3 different types of actuators in your kit in order that you can learn how to use all of these different types. In practice, different types of actuators are useful for different situations, so it's good to know how to use many different types. These actuators here are referred to as RC servos. The term servo really just means that it is one device that has both a motor and a sensor to feed back the motor position. We'll be learning more about that in our section on motion control. These devices are called RC servos because they were originally developed for use in remote control cars. We'll be using them here to build some robot manipulators because they have a shallow learning curve, but they also have a few drawbacks. You can't control them very precisely, and while it is easy to control their position, it is not easy to control their velocity. For more control, and once you have advanced in your robotics knowledge, you will want to switch to using motors that you can control more precisely, like this little motor here. This is also a servo because it has a motor and it also has a sensor to feed back its position. But unlike the RC servos, with this device, you have to do the control yourself with some type of computing device. This gives you more control, but it also requires you to know more about how motion control works. We'll be learning this in our section on motion control. Your third type of actuator, which looks like this, is called a stepper motor. It's another type of motor that can be used to easily control position, except with this device you don't need a sensor to feed back the position. Speaking of feedback and control, we haven't yet mentioned the third engineering area represented by your kit parts, computing. You have in your kit a device that looks like this, called a PSoC 5 LP. PSoC stands for Programmable System on a Chip, and it will serve as the brains of your robot. This device is a type of microcontroller which can be programmed with a computer, then embedded in a robotic device and run off a battery. The microcontroller has a number of input-output or I/O pins that can be used to read sensors, do calculations, and control actuators. One definition of robotics as a field refers to the study of those devices and systems which consist of all three subsystems, electrical, mechanical, and computer, working together in a single system. This class is arranged in a way that is a little different than classes you may have had in the past. Robotics is a field that is both very theoretical and also very applied, and so this course is designed to give you a strong foundation both in robotics theory and in robotics skills. Each unit of this class focuses on teaching a piece of robotics theory along with building, programming, making tasks to help you apply the theory. Each unit consists of one piece of knowledge that you need in order to be able to complete the final challenge at the end of the class. A final challenge is a specific project that you complete to put together all of the knowledge you have gained throughout the class into one big working device. For this class, the final challenge is a working SCARA type pick-and-place manipulator that uses a camera to automatically find the location of an object placed on the board, then moves the manipulator to pick up the object, then moves to a different fixed location and drops the object into a receptacle. Before we jump into robotics study, there are some preliminary setup steps you need to complete. Work through the next 5 videos to learn soldering and finish setting up your kit, to install the necessary software in your computer, to write a couple of test programs in PSoC and Python, and learn to use an LCD screen with the PSoC for debugging. After that, we'll jump right in to study kinematics.